Hello my friends and welcome to my channel. Coffee is ready, so let's begin the tutorial. Today I'm going to edit this image from Mark Wilson from the Facebook group PixInsight for Beginners. This is a Seestar S50 image and it will be a beginner's level of editing. I would like to use only native tools, but I will use some paid plugins as well. First, you need to know this green line represents that this image is in linear state, so it is virtually stretched now. The real image is go to all processes and go to ScreenTransferFunction. This is the first tool you will use when you're beginning in PixInsight. This tool actually stretches the image, but virtually, not completely, just to see what's going on the image. The real image is actually, it actually looks like this. This is a linear image and they all look like black images with some points on the image. And that's completely normal. When you use this tool, you have this chain here, and when it's clicked, then the channels are connected, and when pressing this nuclear button, it will stretch the image. Because the channels are connected, you will get some magenta, you will get sometimes a green image and sometimes even blue. It's completely normal, because when you unlink the channels and press again this nuclear button, then you will see your image without connecting the channels in better light. I will not go to details why is this happening. This is connected with the OSC sensor on your camera, and because you have two channels for the green, then you'll have this kind of image when you link the channels. Nothing to worry about. You just unlink it and see what's going on. This is the important part because you have to see what's going on your image. Always check this part. At this position the tab is green, and you always know you're working on your linear data. Once you stretch it, you will not need this tool anymore and the green line will disappear, like so. You see? No more line. So that's the indicator that you are in the linear mode. Next thing to do, it's very important. You can leave this tool open because you'll need it. The next tool is actually DynamicCrop Tool. DynamicCrop. Go to processes. I always go to all processes and look for the icon. It's a bit harder that way because you have folders here and I really don't know where the dynamic crop is in these folders. I am used to go on all processes and just click dynamic crop. Let's find it. Let's see how many minutes will I have to go to find this. Nope. Oh my god, where is it? Of course, geometry. It's in geometry, dynamic crop. So you can go all processes, dynamic crop or geometry. Okay. Now you have to inspect your image. This is very important. Just zoom in and go to the edges. Just scroll up. You see this? This is a potential problem because this is an artifact of stacking. Because your frames are moving through the night, it doesn't have the perfect alignment of the frame you chose. So when you stack all the images, you will have this artifact. It's completely normal. We all have this on some edge of the frame. It depends how the camera was moving through the night. And this part you have to crop. So you can use this tool, click on this to select the image. This is a dynamic tool. It's linked with the image until you either confirm or just cancel the option. So I want to crop this part, this top part. You can go like this and just crop it, or you can grab the corner, press Ctrl or Command and use this to make the aspect ratio the same. I want to use the aspect ratio the same. I will just reset it because I want to frame this to have this alignment. The core and this galaxy, I want to align it in the middle. So I will crop this part and this part. You don't have to do this, but I like to make it so the frame is better looking. And just press execute. And now you will have this disclaimer because this image is already image solved. It has the astrometric solution, and when we crop with the dynamic tool, we will lose this astrometric solution. Well, I don't like this, and I think this tool can be better to not remove this solution, but it is what it is for now. Just click yes, and we will image solve it again. We can now again image solved. Just go to the script, astrometry, image solver, and this you already have this data inserted in the image itself. Seestar does that, and for this solution I have my Gaia DR3 package on my disk, so I will use this particular set of data to calibrate the solving. You can use automatic and it will connect to one of those catalogs on the online database, and it will solve it also. But I use this because it's a better solver for me. So just click OK because all the data is here. If you don't have this, you have to write down this data. You don't have to have the longitude, latitude, but write ascension declination and the date. And of course you can go to search, and when you go M31 for example, it will find it online and it will give you the coordinates that you must have for this particular object. I will cancel this because we already have this, and the focal distance is from Seestar and the pixel size also, and just click OK and it will solve the image once again using my catalog from my disks. Now comes the first confusion. Let me move this to the left. We have to remove the gradient from this image. And the confusion about the gradients is that you have many gradient removal modules. Let me find them here. Background modelization. Here is the first one. Here is the second one. These are the oldest modules for the background. And now let me find gradient correction. Here it is. We have gradient correction and we have multi-scale gradient correction, or M.A.R.S. We have 4 native, and then if you go on top of this, you can even go to GradientCorrection. This is a third-party gradient, and now this is of course very confusing thing for a beginner. What the hell I'm going to use here? So I will be clean as much as possible to explain what can you use and what is the best thing for your specific setup or images or wherever you do. The only thing that I don't like is when watching some tutorial and the guy says use this specific tool for the gradient removal. Does he has identical images that you have? No, he doesn't. And this is why I don't like when some tool is pushing you to use it, but it's not doing a good job. You have to assess this, what the best tool is for your particular image. And you can only know that when you start using it. You must try it. You must try this tool and then you must try the other tool and see on the image what happens.
If you're doing it, stop it. Get some help.
And that's, for me, is the correct way for the applying the gradient correction, because you have 4 native tools and you have 1 third-party tool, and maybe there are even more that I cannot think of in this moment. But this is the first confusion, and this part is very, very important. This gradient removal is the most important thing you have to apply on your image, because this image has a gradient. You can see this part is a bit lighter than this part. That's a gradient. So we have to remove that to have the seamless background in this image, so we can proceed with the color correction and etc. I will separate these tools by their usage today. So we have automatic background extractor. This was a default gradient removal 10 years ago, even more. So it's an old module that is still in PixInsight, but I don't see anybody using this. So it's an old module that doesn't apply anymore. You can use it, of course, it's still there, and if you live under SQM 2200, then you can use this and remove that small gradient that you have on your images, and it will do a great job. So let's put it here. Dynamic background extraction was the gold standard for very, very long time, because it has some very good algorithms, but it's also old and it still can be useful today. But in the words of the PixInsight creators, they are telling you to switch on the newer modern background gradient extractors. It still can be used and it has its place for some artifacts that we don't have here, and that is it. So it's again an older version of the gradient extractor, so I would not teach anybody to use them today. So we will put them here. Now I will go to Grasspert. Grasspert is a free version of the third-party app that can remove these gradients. It's placed now in the module for the extraction via AI model. So this is an AI model that detects the gradient and removes it. For me, it's great for just to visually inspect what's on image when I want to do some fast removing of the gradient, just to see what's going on, and I use it only for that. Sometimes if I'm under a great sky, it can be useful, so it's okay. You can, from this module, you can launch actually a user interface, the real thing. Just click on the launch. And then you can use some algorithms inside the app. Let me just wait until it launches. Here it is. Still beta release. Okay. This is how it looks like. Let me close it. I launched the app, but I didn't export the image. We can export this image to the interface. It will create a temporary file that will launch in the app. And you can now see it's already stretched. And now here you can use some not AI options. RBF is a very good algorithm for background removal, but it's maybe too aggressive for some things. And you have splicing and kriging and the AI model that we can use via module in PixInsight. But I will leave this because this is not a native app. I'm just showing you it exists so you can use it. It also has the convolution and denoising, so it is a great app. It's free and you can play with it if you want, but let me close it for now. Now let's minimize Grasspert. It is a third-party app and put it here. And now we are left off with this two gradient removal. Now we are on two gradient removal modules. We have a gradient correction and we have M.A.R.S. These are the newest module for gradient removal in PixInsight. So what to choose from these two? You can choose either one of them. It just depends on how long you want to be on this gradient correction workflow. And the gradient correction is actually very good for detecting gradients, almost as a default. It can remove very much all the gradients if they are not that strong, if you don't have some artifacts on the image. Here I don't see any. This is a particularly okay image, doesn't have any blown out parts with the sky, so it's actually recorded on a good sky. So gradient correction will be fine for this particular image. Let me just apply it like it is. I just launched it and I didn't change anything. And let me apply it. And it didn't have any gradient to pull. And this is absolutely normal. Because it has structure protection. Let me just close this and let me enable simplified model. Just this two. And run it again. And now it did the job. Before, after, before, after. You can see how he balanced the background, and that's important. Now let me back it up. One thing you have to know is that you can generate the gradient model, and I urge you to do that often in the beginning so you can see the gradient that he removed. That way you can visualize the gradients better once you have 10 or 20 images behind you. What I changed here is the structure protection is actually protecting the lighter parts of the image. So probably it had a very big protection here on the core of the galaxy, and it failed to create a good gradient map for the removal. So when I disabled this structure protection and applied simplify model that has a generation of the simplified map for the gradient, I will also click here to see that model and to see the gradient model from here, just to see what he removed. So let me apply it again. Okay, they are both unstretched because we have a green line, and that means we are in linear mode. Just click here and click here. Let me remove this, and now we can see both gradients. This is the simplified model. He actually extract this first to see it can detect a simplified gradient on the image. If you have something like this, this is very regular gradient from one side to one side to another, like so, and he was able to detect it on level 1. If you have some bigger gradient, you can increase this on 2 or 3. The main thing is I cannot explain what this tool can do to all the gradients. I would have to have one tutorial with many different gradients to explain all the options in this tool. For this beginner tutorial, I will maximize my explanations on just the default options or just few tweaks you can do to apply it on your image, particularly this M31. And we can see this complex gradient. We probably had some gradient here. I cannot know because I don't see it, but let's see the before and after. Yeah, because the gradient is going all over the image and over the whitest part and the stars and everything. That's a gradient. That's definition of the gradient, and you have to watch what's going on your image. It will be hard at the beginning because you don't know what you're seeing here and how must this look, because you didn't photograph M31 ever and you didn't do this editing like never, and you don't know what to look for. The main thing is to look for some artifacts that are not supposed to be there. You can zoom out and see, do we have a clear representation of the background, and do we have this part not affected so much. Let's say this is good. I cannot be 100% sure because we have some dark lanes here, and when we do this, as if we have some signal removed that I don't like to be removed. So let's close this, and let's try let me try to increase the scale, smoothness on 50 and scale and apply it. You can now see, okay, the simplify model is the same. I will not generate this anymore. You can now see this image is a bit seamless. It doesn't have those sharper lines here now because we extended the scale. The scale now looks for bigger objects of the gradient, not small. And this image doesn't suffer from the small gradient patches. It suffers just from this gradient on the top, and it goes to the darker on the bottom left. Just for a disclaimer, this is a process that is most important on the image, and it's very hard in the beginning because you have to tweak some options that will be specific for your setup. These options will change when you have a completely different setup from the different camera or lens or telescope, and that's why this part you have to practice. You have to practice, and after practicing some images you will know better how to apply these options, and you will know to recognize the gradient on your image and apply almost immediately the options for that gradient. So it's just something that you have to practice, and with practice you will make perfect, of course. And when you have like 20 Seestar S50 images behind you, you will exactly know when you pull out the 21st image in the PixInsight, you will exactly know what to set up here for your particular setup. But for the first 10 images, you'll have to practice, and you'll have to tweak these options, and you have to learn this tool a bit to make you a better gradient removal guy. One thing that PixInsight has is when you move the mouse on the option, it tells you some description what it does. So it's a great thing to learn about the slider and the options you have here. I urge you to read those when you're doing something on any tool. It will help you understand more what this tool does. So let's say automatic convergence is actually an iterative process when you have a complex gradient. So it can do iteratively the removal of the gradient, and therefore it will remove it better from your image. For this image we actually don't need one because we have a simple gradient. Now let's move over to the M.A.R.S module. This module has some setup to do before you can use it. You have two databases that you have to download it from the PixInsight website and add them here via this add M.A.R.S files. You need to have these databases. You can have only this database. This is a user database that they are also including. We did provide images to create this database. That's why it's a user database, but the main database is this one. And it includes all the images that have a clear sky without the gradient, and it compares it with your particular image and removes the gradient. The idea is actually very good, but there are sometimes it can remove the gradient perfectly, but sometimes you must work on it as in the gradient correction. So these two, I would suggest one of these two to learn how to use it and remove your gradients. Don't learn both of them in the same time, just learn one of them and then move to the other. So let me show you briefly. We will use gradient correction for this image now, but I will use, let me just back it up. I will click here and just drag this tab here, and you will create a clone of this image. I will go to this image and now I will redo. So now we have the image with the gradient removed here, but on this clone I will just demonstrate the M.A.R.S gradient removal. Let me just minimize this and put it here. So M.A.R.S, when you add the databases, one thing you have to do on your image. First thing is to plate solve it. It must be plate solve, and then you have to go to the processes and spectrophotometric flux calibration. You have to do this calibration first in order to use M.A.R.S. And for this particular options, you have to choose what do we have here? IMX 462 is the sensor on the Seestar. You have to find your sensor here, but if you don't have one, just click on ideal Q curve. The red, green and blue filter, so this is in OSC camera. Oopsie. You can see it here. We have red, green and blue channels. And for all channels we are using the UV ER cut filter. The Seestar has these filters, or has one filter, and I will use my Gaia database that I already use for my plate solving, and just apply this to the image. Some dynamic background extraction is a dynamic tool, so he caught my image. Let me just remove that module. It's exactly the same dynamic tool like DynamicCrop. It locks down onto the image and it won't let go until you just stopped or removed the module from your window, and then it will be fine. So let's now apply this. Nothing will happen to the image. It will just calculate the fluxes of the stars using the Gaia DR3 catalog. If you want to learn more, you can Google it, or you can even see it on the PixInsight website explanation. Okay, it did measure it, and now once we measure this, we can use the gradient correction, multiscale gradient correction, or M.A.R.S. Let's just apply it like it is. It's a good thing now to show you. Just grab this tab and now move it down here, not here, not here, but in this gray line. When you move it, you will create a preview. And this preview is actually from the whole image. You can create small previews like this, but now we don't need one. And when we have a preview, we can apply options to the preview without applying it on the original. Let's say this is just a virtual virtual execution of the module on this preview, but just to see what happens to the image, so we don't have to go undo and redo all the time. So let's now click on the preview and just default options. Let's see what it does. This is our clone with the gradient still on, and it did this. Why it did this? Because there is option here, show gradient model. It's automatically enabled, so that's why we see just a blank gray thing. And that's a good thing because we want to see the model, the gradient model. It's totally different than our gradient model that we had on the gradient correction. And now you can see the difference with these two models and these two gradient maps that it created. And now let's see what this particular gray thing will do to our image when we apply it. Again, I can apply it to preview because it didn't apply it on the original. The preview is still the same. And we can click here, this not reset here. This is actually undo preview. So we can see the preview, the undo redo preview execution. And we can now see, let me zoom out. This is not that aggressive. This is before and this is after. And you still see this black thing here and this white thing, brighter thing here. It didn't remove the gradient as well. And we can see that. You can see it with your eyes, and you always must look with your eyes what is done to your image, not just blindly applied to the image. Look at it. Look at it, man. So for the M.A.R.S, I would say that the M.A.R.S is a bit of a weaker option for the gradient removal, and the gradient correction is a bit more aggressive version of the gradient removal. For this image I would use gradient correction because it's more aggressive and it can as you can see, it can do a better correction of the background, and it would equalize these parts of the image. The important thing is that you look at the image and try to recognize what is the gradient and what's not the gradient. As I already mentioned, this is a practicing stuff. You have to practice this and see your image. I know it will be hard at the beginning, but after a while you will understand where is your gradient coming from and how to remove it, what tool to use to remove it seamlessly without any problems. So we are still on the preview, and what we can do here, maybe to boost up the scale factors, let's say 2. Now you have to tweak some options to have a better gradient removal. The model smoothness, the smoothness is good enough. Structure separation we don't need because we have a seamless gradient, and the gradient scale, it's fine. The gradient scale is actually okay. Don't have to tweak this. Let's just apply this and see what happens. So this is a bit better, but not good enough because it removed this part. Maybe it's actually okay because we have a similar background here and similar here, and the Andromeda is shining. It's gradually losing its brightness as we go this far. And this is one suggestion. Again, learn your object that you're photographing. Don't just photograph it and edit it as is. Learn how the structure of the Andromeda is on other images. How does this part of the Andromeda is on the background? Does it have a sharper edge? Does it have a gradient edge for this particular image? Yeah, it has a gradient edge that slowly turns into darker tones of the space. So let's say this is actually a good removal, but I still don't like this part, but we will leave it. We will leave it as is, and we will now try to edit both of these images for the final version, just to see what the difference is of these two different gradient removals. Again, I'm repeating myself, but this is the most important part of the workflow. If you mess this up, you will just have problems later on. So you have to practice this, and this is important. So now we have this applied on the preview. So it didn't apply it on the original. Go to the original. We can close the preview, just go to preview, delete all, and now apply it again on the original image. And now we get this. Let me minimize it. And now we can rename it. Let's just double click, new identifier, and 31 M.A.R.S. So we know this is an image that we removed the gradient with M.A.R.S, and again on this image M31/GC gradient correction. And now we have two images that are already different. The background is seamless and the background is more realistic here, so we will see who wins in the end. Now I will apply the same options on both images as we go on. Now you can apply, as we can see, the stars are a bit off, and if you have a BlurXterminator, we can fix this some more. You don't have to do it, but only on this top right hand we have some elongated stars. So if you have BlurXterminator, just apply it with a regular correct only. I will do just this and apply it on both images. Before, after, before, after. Now the stars are much better. Again, on this image, same thing. I'm applying the same thing on both images. Okay. Oops. Okay. And now the second most important part is the color correction. And this is again something that is confusing to the beginner because it has different color calibrations. We have background neutralization, the first one. Color calibration. Photometric color calibration and spectrometric color calibration. And of course, this is all confusing for a beginner level user, and I don't blame them. It is confusing if you don't know what to use. I want color calibration and that's all. Why do I need to have all these tools and not know what to use? And some guy said this, use this, and this, use this, and some other guy, you have to use this and this. I will show you what it does and you will choose what to use. I will just have a suggestion what to use for this particular image, and you'll choose for yourself. You can even see what is the differences when you use all of them and see on your image. So let's start. First of all, background neutralization. I did mention when you stretch the image like this with the link channels, you have something like this, and this is the tool that will equalize the channels to have a normal looking image when you stretch the image with the link channel. So let's apply this. I always do that. You don't have to do that, but I like to clean this before applying any calibration. You can see on these tools, let's say color calibration, you have a background reference. Here on the Photometric you have background neutralization, and here you have also background. So these tools have these options already included in them. So you don't have to use this tool at all if you're using one of those options. This is just something that is left off from the old days when I did this often on every image, because I didn't have these tools for color calibrating. We only had color calibration and that's all. So we had to neutralize the background first to make the color calibration more accurate. And now we don't have to, because we have these options in those newer tools. But let's say for this user, for Mark, I will show how it's done if he want to use this. Just unlink it and stretch it and find some black. You have to find a reference point with no nebulas, just a blank space on the image. Anywhere you like, and let's say this part, this particular part. You have to go on this icon. When you press it, you can now select a region like so, and this is a preview. Again, we are creating preview, and preview is here. And you can click on this preview, hold the mouse and just drag it into the region of interest. And now the background neutralization will use this coordinates of your image that this preview has given it, and use this part of the image to neutralize the background. And just you can move this slider, new instance, or you can, by new instance I mean drag it here, or you can just apply this button square, but you have to have selected this image. Okay, now it's done. And now when I link the channels, we will have this. The color will shift because now we have neutralized the background, and this is okay because we didn't do any color calibration. So let's do this again on this image. Let me choose this part from the preview again here and neutralize this thing. Kaboom. Very similar, but not that similar. This is more reddish than this one. We will see later how this applies on the calibration. So this is an option that you have here, and you can use this same thing on this both modules. So let me close this one. So color calibration is an old module that we used before these two, and those two are superior. Actually, this one's old, and then the photometric came. This one's better because it uses a catalog of the broadband stars to compare it with your own stars on the image, and then apply a calibration to fix the colors. And then we have SpectrophotometricColorCalibration that uses a Gaia catalog, which has far many options and far many details of the stars than the regular catalog. And this is the most I think this is the best one for the color calibration. When it arrived, I never switched to any of these older modules, so this definitely is the best module for the color calibration, thanks to this Gaia catalog. You have to have this Gaia catalog on your drives to make this possible, and believe me, you will be happy how this module corrects the colors. Since this is an older module, I will not use this. I will just use this too. Let me apply photometric color calibration. Again, background neutralization, you can leave it as is. It has some options here that will apply on the image, but you can have, I deleted those previews. Let me get them back. I have to create another preview. So okay, let's do that here and here. And now let's drag it here, and white reference is a spiral, average spiral galaxy. Leave it as is. And for the catalog, just leave it as automatic. It will link to some website to analyze, to download the catalog and analyze your image against it and fix the color. And that is it. Let me stretch it again, and now it's looking much better. Again, preview here and apply it to the image. And now let's see, are the colors the same on both of these images? They are not. You can see the calibrations are different. This is still more reddish, and this is beginning to be more flat, which I like better, as if some of the gradient was left off here and we have some red residual. As you can see also here, we have something here and it's empty around here. Probably it can be a galaxy, but it will glow this far. It will glow here as well, not just here. What is this? So something is a bit off on this image, and we will see later what it is. So I do like this better. Okay, this is a photometric color calibration. I will not clone those two now to have 4 images. I will just undo this photometric color calibration and see what spectrophotometric color calibration does. The differences will be probably very small because this is a good quality image and it doesn't have any problems that would affect the color calibration. So let me close this, and we are now off to the main guy. Okay, let's just undo the photometric for both images. Now when we link the stretch, we will go back to the previous versions. Okay, preview again, drag it here, background. You don't have to do this, but I do it. And we have to set up something here. Again, average spiral galaxy, QI curve. You can use your sensor, but the sensor on Seestar S50 is 462. We have 461 here, so I will choose ideal QI curve, QE curve, not I, because I don't have a sensor on the list. Again, we know it's a sonic color sensor with the UV IR cut filter, so we are leaving this alone. If you have another sensor, or you have, or let's say L Ultimate on your sensor, then you have to choose this option, so it can calibrate against your own setup or your own camera, because it has to do this. It compares the Gaia spectrum of the stars against your image via your setup, via your sensor options and details, and then it can calibrate the colors even better than any tool so far. Okay, just apply it. Of course, you have to have the catalog, the catalog of the Gaia DR3 stars. It's important to have this. This will not work without the Gaia catalog. Just download it and have it on your disk drive and never look back. Okay, it's done here. Let's do this. Of course, preview on the region of interest and apply this again on this image. And again, we can see the differences. I did mention that the colors will be probably the same as the photometric calibration. Let's just stretch it again. When you have something done to your image, especially gradient and color, the virtual stretch must be resetted because it was left over on the previous options. So you have to restretch it. Just press on the nuclear button again to see it. It's still in linear mode. We have the green here, and that is it. This is our two color calibrated images. They are a bit yellowish, especially this one. Reddish, I don't think this will work, and I really think this will, because M31 has some bluish on the outer part of the disk, and we will see if we can pull that out. And now the third most important part is the stretching, or making the image from the linear state to non-linear state. And again, this is a very confusing stuff for the beginner, because you guessed it, you have some different tools for stretching, and let me pull them out. First of all, oh my god, where is it? Okay, we have GHS. This is not a native third party, very good. We have histogram transformation. We have MultiscaleAdaptiveStretch. We have now, oh my god, let me remember some old ones that are here. Okay, where is it? Come on, my brain is melting. I can't remember the name of the tool. Damn it. Let me see. The image intensity transformations. Oh, here it is. So intensity transformation, exponential transform. Okay, I will leave that as is. Mask stretched. Oh my god, this is insane. I think that is it. Adaptive stretch, of course, I forgot that. And this is only let's generalize. Hyperbolic is not native, but you can see how much native stretching modules we have. 1, 2, 3, 4, 5, and then we have GCS, which is third party, and then we have scripts, and I can count maybe 5 even more stretching scripts that you can use from a third-party developers for stretching. And this is insane. Of course the beginners will look at this and say, what the hell I'm supposed to use? I will try to help you to use only one for this particular image, and maybe for 99% of the images. First of all, we did use the histogram transformation, was used like many years before. This all modules were capable of stretching, and most of these are obsolete. We don't use them anymore, especially Arcane Stretch. That's an old module that we don't use. We don't have to use. You can try it and play with it if you want, but there are better solutions now for stretching. So I can disqualify Arcane Stretch immediately. Mask stretch also, it was a very good tool for stretching until GCS and multi-scale adaptive stretch were invented or created. So it's also obsolete if you ask me. Play with it if you want, but I think this stretching module is out of the workflows. Adaptive stretch, it's a cool thing because it can read your image and stretch it automatically, adaptively. This module is actually overridden with this newer model. Multiscale adaptive stretch is actually the newest one in the PixInsight, and I think this is obsolete once we got this. So histogram transformation is an old way to stretch the images. I will not show it because you don't need it, so I will close this. So again, we are on two modules. And this is a third-party module, so you don't have it in your PixInsight installation when you install it. I will just briefly mention this because this is a great tool and it gives you very good options, and it gives you a very wide set of possibilities to stretch your image. It's a bit more complex and it would deserve a tutorial on its own to show this. That's why I'm not gonna show you this, because it's not native and it's a bit harder to understand for the beginner. And I think the multiscale adaptive stretch is in par with this and sometimes even better. So that's why I'm going to use just this module. So I hope so the confusion will be over by now and you will just use this module for stretching from now on. And if you have troubles, you will go to see the GCS module and learn how to stretch with that module if you want to. But I think this will stretch your images good enough to have a good Astro image at the end. So let's try to stretch the images. Once again, we have a background reference. What is that? We had something similar in the previous version. We had to mark the specific background reference, right? And that is exactly the same as we did before. This is a reference of your background. You have to reference this as a background, not on the nebula or any signal. You have to find the part of your image that is pure black space and use it here in your reference. You don't have to use it, but it's fine if you do, because it will tend to have more accurate stretch. Just again, pull this and move it over here. It's that simple. So let's now stretch the image of the M.A.R.S gradient. Now you can use this ScreenTransferFunction to remove the virtual stretch. Just press this monitor here and we will get back to the original viewing of your linear data, because we will press this live view, this circle, and it will open our image in the time preview, real-time preview. And now we already see the default options are stretching the image. We didn't do anything. It was just a default option, and it's already looking great. The image is stretched. You can use this option to zoom it, and I'm actually liking this. This is actually a good stretch. Okay, let's tweak some option. Target background, just move the target background and you will have some more stretching. Let's leave it as is. It was on 150. Aggressiveness will pull some signal more from the data, but you will have a ton of noise in the image, so don't push it too hard. The main thing is the galaxy, right? We have to concentrate on the core of the M31 because you can easily over brighten it and then you'll have a problem. Pressing on the core with the mouse and holding the mouse, you can see these values, and these values are left are the values when the image is linear, and on the right the values are of the stretched image. And let me zoom in and press it again, and you can see the values are 0.99, 0.97, 0.95. These are channels, red, green and blue, and we are not pulling this overboard, because if we have one, now let's stretch it some more like this, even this is okay. Let me pull this all over. Okay, you now see the red is 1, and that is overstretched pixel. We don't want to see the 1. Okay, let's just reset the whole tool. Be careful about this. Let me zoom out. Okay, let me just stretch it a bit here. Dynamic range compression. You can see what it does. It will tend to lower the brightness of the stars. And that's maybe needed here because of those two cores of the galaxies, but not very much. Just like so. This for me is playing with the sliders. You have to play with these sliders. Oh my god, I lost my background reference because I reset the tool. Let me get it back. Come on. Press here from the preview. You can go like this also. This was a M.A.R.S. Yeah. Now the difference is when you don't have a background reference, the more stretched image is without the reference. Okay, contrast recovery. This is something you can see this. We don't want these sharp edges. This has to be smooth as much as possible. We will have some overblown cores if we do this, and you can just play it. Maybe sometimes you'll have to lower this down for some particular objects, but for this M31, these default options are good enough. Color saturation is just making the stretch with color already enhanced while stretching. This is a very good option because we always had to stretch it and then boost the color saturation, and this does the same thing on the stretch itself, and it has a lightness mask, and when we click it, it will boost the saturation on the background, and that's something that we do not want, because we'll have something like this. When I apply lightness mask, you can see the difference before, after, before, after. It masks the background pixels and apply the saturation only on the signal, on the brightest pixels. And let's say I'm satisfied with this. Just click on the apply, and now you can see in the background it applied the stretched image, and then again, because I have this real-time preview, again he applied the same options to stretch it even more. You can double stretch it if you wanted, but you will have some interesting things going on. Let me just close this, reset the module, and okay, this is our yeah. I did the wrong stretch. Yep. The background reference was not from the M.A.R.S, it's from the GC. Okay, my mistake. I will just do this again. I didn't change much, just a bit so far. Okay, let's say this is okay. Close it, and now we will go to M.A.R.S. From the preview, we will select M.A.R.S preview. I'm selecting this preview for the background reference. Again, click on this, and now we will have the M.A.R.S N31. It's a bit different. I can see now the gradient was left over the galaxy. This is not a natural looking M31. I can already see it, but I have experience with this galaxy, so I can see the difference. When you're beginning to edit, you will probably not see the difference. That's why I suggest using gradient correction with the default options rather than M.A.R.S. And that is it. That's why I did create both of them, to see the difference when we stretch the image. Let me just lower it down now, because we have some gradient all over. The image is brighter. It has more pixels and it will be brighter than the regular. Okay, let's click this and remove this. And now we have a stretched image. I'll remove the preview, remove this preview, and we can remove this module, and of course we can remove this. And now we have ourselves a non-linear image. So we got this far, and now the other fun begins. Now we have to edit this image to look even nicer. So looking at these two images to compare, we can see some details on the galaxy here. They both have some black stuff on the edges, especially this one. And this has, I think the gradient left over has this part not removed. That's why we have this artifact. I will not continue with this one because I clearly see this will not look good. And you can now see mark that the GC was better. And you can do this also, create the clone and do the similar editing, or once you do the gradient removal. So you can later see which one is better, and you will see in time which one when you familiar yourself with the object you are photographing. So N31 is fairly popular object, and I did see a million images of Andromeda, and I can see when something is a bit off, and then apply a better gradient removal or color correction or whatever. The M.A.R.S is gone. From now on, from this point on, we are applying an artistic expression. From this point on, every image will be different, because we all have different eyes and we all have some different thoughts of how some object in space look like. You can use some references that you like. We always do. We look some images of better astrophotographers or astrophotographers that are on the better sky, and they have some better images than us, and they are also, as a reference point, something to mimic and try to mimic, to have a closer look to those kinds of objects that we like. But again, you rarely see two N31s that are very similar. Everyone has its own definitions of how the color work, how you see the color, how you perceive the color, how great or bad the monitor you have on your computer. So this will be different for everybody. I just want to state that so that you want to know that this part will be just my interpretation of the M31 photograph with the Seestar S50. You can follow my instructions, of course. It's a good thing to follow them, but in time you will change some things that you don't like in my workflow, and you will create your own set of tweaks for your particular imagery, and that will be eventually your style of editing. My style, I tend to be as scientific as I can, but over time I did some tweaks that I like better, like some maybe I saturate stars a bit more than usual, then it would be scientifically correct, and I did some tweaks. But my evolution of the editing is, let's say, not that aggressive. I didn't go as far as like some astrophotographers would. So from this point on, there are many tools you can use. I will try to minimize what tools you can natively use to make this stretched image a bit better. Some things you can use the third party like noise exterminators, star exterminators to make it better, because without stars we can manipulate the pixels easier and make this galaxy a bit better with the stars gone. So let me do that first. We will remove the stars because we have, this is not a native module, but I think the PixInsight is working on the AI models that will remove the stars and do the noise extraction and even sharpen the stars. So these tools will be eventually native. We can use Star Exterminator, and you can use StarNet, which is free. I will use Star Exterminator for this and just remove the stars. Don't touch anything here, just generate star image, unscreen stars, and apply the option to your image. And the stars are separated, and now we have a pure galaxy and stars. When we didn't have these tools, it was a bit difficult to edit with star zone. You have to have masks and all sort of stuff to minimize the effect of the changes on the stars and just on the background. And when the StarNet was out, I don't know, 2018, 19, somewhere 7 years ago, it was a big game changer, because we did this then and the images turned out much better when we had this tool given to us by Nikita for free. First things first, let's fix the stars because it's easier. We will Mars is gone. Minimize this, leave it here. So you can inspect the stars. Just zoom in. It's a purple star. We don't like purple stars because there are no purple stars in the space. We have to fix this. How do we fix this? I will show you. We also have some green. This is a bit yellowish, but it has greens. Also, we have greens here. There are two tools we can fix this. I do this always, and the stars are looking much better. First, go to processes, all processes, and find SCNR. This will remove all the greens from your stars. Let me just zoom in some part where I see the greens. Here it is. Just move it over to the image, and you can see here the star is not green anymore, and here it removed the greens and star is now yellowish and reddish. A small tweak, but very important one. And now for the magenta stars. I know the Seestar S50 has problems with magentas, and you can see this all over the place and all over the stars. And there is a good tool for this. It's native. You just go to scripts, utilities, and correct magenta stars. You only do this for this kind of stars. If you have a Seestar that has magenta stars surrounding the cores, you can use this tool, and it corrects magenta stars. Easy as it shows. We don't have any masking, just apply. The amount is 80%. It's good enough. Just execute it and it's done. You can see in the star, maybe it's too aggressive, I would say. Let me undo that and run it again at the lower point. Let's say 61%. Okay, this is far better. There are some residual, but I will leave it. I will not change this. And now you can go to all processes and curves. Curves transformations, or transformation, not plural. This is a great tool for everything regarding contrast and lightness and darkness of your image. You have some options here, and you have a line here. You can click on this track view to have like this, and it will show here, it will show a histogram of your image when you connect it to your image. Because this is all black and some stars are only active, there is not much of the histogram here. But what I want to do is go to this S tab, and this is a saturation, and just boost this up, and you can see it in the real-time preview. Just click here, click then here and make a selection to see the stars closer, and you can click this circle here to have before, after. Before, these are regular, and these are saturated. Maybe I'm too aggressive with this, but you can go here and you can go here, and now this is that artistic part that I was talking about. This is just your choice how much you want to saturate your stars. You can go this far and it will look awful if you ask me, but some people do it and it's okay. Everybody has their own style. I will suggest just a little bit to have those stars as natural as we can. Here it is, a perfect point. You can apply it and remove this preview. And now we have before, after. I think this is good enough. And that's it for the stars. So now back to the Starless image. There are 3 strategies to move from here. First one is, do you like the contrast? Second is, do you like the color? And third is, do you like the noise? And there is a lot of noise in the background, on the signal less so, but it has some. Definitely needs a good noise cleanup. But before we do that, I always like to do the noise reduction at the end, once you process your image. The main thing is, do you like this flatter version of Andromeda, or do you want some more contrast? And for that you can use your, again, curves transformation. Go to this real-time preview and now go to RGB, and now you can use this. Of course, I will click here to see the histogram levels, and now we can use a regular S-shape curve to maybe have some better contrast. And here it is. Now our cores of the galaxies are getting maybe a too bright, so maybe I will lower down this to lower down the brightness of this one. You have to be careful because this is the highlights, this is the midtones, and these are the blacks. So we are toning down the blacks, so we have some separation of the black tones with the brighter tones. We have to be careful because we have some details here. We don't want to tone that to like here to don't see it, so we don't see it. Just casual weak S curve, just to make it pop a bit, but you can see it's a very big transformation. And now you are looking at what can be done with this. As you can see, we have this filaments in the galaxy, and when we apply contrast, the filaments are looking way better. Now you actually play with your image and try not to get too excited and make some crazy edits with it. On this part I will show you just a couple of tweaks, because this can last forever. We can go into so many details with masking, with applying sharpness to the filaments that are black and filaments that are brighter, and so on, until we get some image that I will like. But that's not the point here. The meaning of this tutorial is to show you the tools from which you have to use them in your own editing. And for this part, because you are the beginner, overwhelming with tools would be maybe too much for the first images. The main tool is the curve transformation. That's, I already showed you this S curve and the saturation that you can do. Let's reset it, and let's say we want some saturation added. I will not use the preview now, just slight saturation, and move it here. And now we have some more yellowish before, after, not that much. The blue stuff on the edges is not there because the blue signal is very weak here, and only signal that was left are the reds and yellows, so there is no blues here. Maybe if you had much more data it would turn out here, but on this image it's not visible, so it's not going to show, and that's okay. We just want this core and the surrounding to look better. On the other hand, if you have some magenta or reddish, that are parts of the H alpha in the image, because the Andromeda is full of these little shapes, details of H alpha, and without filter it turns out a bit magenta and very low saturation. And if you photograph with the H alpha filter, then you have those images with prominent grape-like structures across the whole galaxy. And that's when you see this, you immediately know that it's photographed with additional H alpha filters. And for this we are just making it to look nice, and this is looking very nice. I'm seeing some yellow, some greens here. You see this. This is a bit of unwanted signal. So let me close this and let me pull out again the tool that we already used, SCNR. So to remove these greens, but I will not use the amount of 100 this time. Preserve lightness must be on. Let's lower it down to 50 and see what happens. We want to remove those greens from the image. Not liking the greens, and here it is. We did tone it down. Let's see before after the whole image. Yes, this part now looks far better. Before, after. Before, after. Don't be aggressive on tools. You can always lower down the percentage that you are applying. There are some greens here. So let's say this percentage wasn't enough. I want to maybe even 65%. So I'm looking at this part. This is a nice H alpha grape. You can see it's reddish. Very nice. And this is looking better. Before, after. Before, after. Always do your before, after, so you can see how much. I 65% of SNR, and we have much better looking result, if you ask me. Just this tiny bit of green removal, we have better colors on the galaxy. I really liking this. So far we used what? 2 tools. We can use also histogram transformation. It's similar to curves, but it acts differently. Let's open the real-time preview, and now you can pull the slider and you will have the black toning down. We can manipulate the mid-tones here like we want to. Maybe a tiny bit to the left, and we can even brighten the course, but it looks awful. And now apply it on the square and remove this, before, after. I like it a bit more brighter than usual. I don't know why. I'm just used to a bit brighter images. You can always press here and see the values in pixels. When you press here and hold the mouse button, you will see RGB 0.18, 0.14, 0.18, and I always tend to go 0.11 or 0.15 for the background, but this particular image has the gradient of the galaxy going to the black part, so we don't have the pure black pixels here. We have some residuals here. We have a blackened part and blackened part here. This is probably from the extraction of the gradient, and that's an artifact. It's very hard to see it when you have a linear image, and this is something I would maybe brighten it a bit with a mask, but it's fairly visible. and it's not making the image worse, much worse than it is. It's not worse. The image is great. And that is it. Now, as much as I looking at this image of Andromeda, I'm seeing that something is a bit off, because Andromeda tends to do that. It tends to go a bit yellow, and that's something you cannot register when you're doing a beginner's level editing of Andromeda, because it's a hard target to edit. Even I didn't notice it until now, and this can be solved by a little trick using a module that is actually no longer needed for color calibration, but for this kind of stuff it's absolutely great. So I will show you how can you balance the colors without moving any sliders when you have something like this, as if it has some yellowish color cast. Because I did mention it that I didn't see any blues around here, but this is a bit extreme. I should have seen some of the blue pixels, so we can do this. Go to processes, all processes, or let's go color calibration, and click on the color calibration. I discarded this module for the calibration when we had the image in the linear mode. Now I will use it for this stretched image, and this is how we can do it. We will apply 2 previews. Click here, and the first preview will be like that. I want to exclude as much as I can of the black parts, and the second I will use this part. We don't have any stars, so I know this is our background. For the background, I will drag all over here, region of interest. So we can discard this, we can drag it here also, but we can drag it on the region of interest. And for this part, for this preview, I will drag it again on the region of interest. So the background is dragged here, and the first preview is dragged here as an white reference. So he will use the pixels from this preview to have some white reference for the adjustment. And now let's just click apply, and we got something. Now we can see much of this yellow is gone, and now we have more of the reds are gone than yellow. We have some residual here. Let me now delete those previews to see. Now maybe it's more accurate, but it's a little bit flat on the colors. So we did the color calibration on the stretched image to make this Andromeda more like it is in real life. And now I can see some bluish pixels here that are present, and I'm liking that. We just lost some saturation because we did boost it, but we boost the red ones, and now we can boost everything else. Again, curves transformation, press on the S. Let's see the live preview. And let's see when we boost it, what do we get? And now you can see the blue pixels are coming out. So there are blues here, and that's great to see. So Mark, you did catch some blues. Okay, we will not go that far. We can do this, and we can see it now. And now I can see these are real colors, because you can see this red stuff is H alpha, and also here, and we can see this is some blue reflective nebula probably. I know the edges are bluish and the center is yellowish and reddish. Now we have those greens that we didn't remove all the way, and that's fine. But we don't have to use this kind of saturation, but let's boost it like so. Click OK. And now we have very different Andromeda. I do see some greens in these yellows, and this is only possible with someone who has done many of these images. You will not see the green in yellows. I see them because I can recognize those greens when the yellows turn to yellow-green color. As you can see before, after. The yellow must be a bit of an orange, reddish, not a yellowish greenish. If you can call that yellowish greenish. This is just an experience, nothing else. From experience I can see there is some greenish in this part of the nebula, of the galaxy, and I did this. Maybe this is too much. Let me lower it down to 48% and now apply it. I'm liking this result better. And here it is. Now the colors for me are the way it should be. There is only one thing left over, and that's noise reduction. I didn't do noise reduction until the end, because when you changing the pixel values, you can introduce some more noise once you do the noise reduction. So for me, I suggest that you do the noise reduction at the very end of the editing. Of course, after noise reduction you can make some tweaks because some details may show up and you can edit it some more, but for this image we can do the noise reduction. Now I will do the noise reduction with stars on, because when you do that on the Starless image, you will reduce the noise, but the stars has those glows that are gradiently lowering down the brightness and partially are noisy. So you will have noiseless Starless and good stars, but the glow will be noisier, and that will blend with the background, and that then doesn't look good. So let's blend the stars. Go to Script, Utilities, and you have a blend utility, blend script. The upper image will be our image N31GC, as so, and the lower image will be our star image, GC stars. Let's first remove the auto STF. We don't have to stretch this, and overlay mode we have to set up on screen, because we ran the Starless image with on-screen option, and click ready. I don't know why he did create lots of blends here. We don't need these images, we just need the blended one. And just for fun, you don't have to, but I suggest you save the Starless and star image. Maybe you will want to re-edit some stuff, and it's always good to have them separated so you can have both versions ready if you want something to do additionally. And now we have the stars and the galaxy all in the image, looking great. It's noisier, and that's fine. And now let's apply noise reduction. Of course, I use Noise Exterminator. You have some, you can use GragSprit, you can use DeepSNR, that is free, those are free. And I know the PixInsight team are developing already the noise, the reduction via AI for the whole systems, available now only on Macintosh. I don't have a Mac, so I'm using Noise Exterminator for now. Let's just apply it like so. Maybe I'll go to the real-time preview and see what it does on this option. I will just zoom some parts like so, before, after. It's already looking very, very good on the denoise 70%. I don't have to do anything, so I'll apply this default option. And look at this M31 with a Seestar S50, my friends. Looking great. Let me zoom in. We have these filaments, we have this little bluish thing. We have this reddish thing. This is looking great. Stars are good. And overall, a great Seestar image, if you ask me. And you can now see how much you can pull out from this kind of images from the Seestars. And today Seestar 50 Pro came out, so even with a bigger sensor, so probably better images will be created with that technology. And I hope you like this tutorial. It's a bit long, but I want to be precise in explaining the tools, especially for Mark, who is starting out, and I'm using his image to try to explain the best that I can, so he can repeat this same thing for this M31 and make a great image out of it. This is where we started and this is where we end up. Remember, this is a basic tutorial for a beginner level PixInsight user. I didn't go overhead and fix every little tiny detail here. I just wanted to show how you can get from this linear image from Seestar to this image that a Seestar user will be happy with. And that's all. I did explain that in the process when you stretch the image, everything will be different, because you will develop your own style and you will edit colors and noise and contrasts differently than I do. So it will tend to deviate from this kind of editing, and that's fine. If this is something that you want to have, it's also great, and I'm happy you will like this kind of edits. And this is it. I hope you enjoyed. I hope Mark will understand every tool now and edit his photos in some fun and easy fashion from now on. No, and like I said, this is an ongoing project. I will have more videos like this for some basic editing, and you can learn much more. On that note, if you want to learn editing in PixInsight, join my Patreon. I'm building a community there where we can communicate easy, and I will post there every kind of video for basic editing, for intermediate editing, and for the expert editing, using my tools, using native tools, and using third-party tools in PixInsight. So I hope I see you there, and that is it for today. Bye bye.